In this lesson, I will be covering how to solve for x in a given problem using basic trigonometry. So the three aspects of simple trigonometry is sine, cos, and tan. Now, sine, and we'll be referring to this as sine of theta. So sine of theta is equal to opposite over hypotenuse. And this can just, an example of this would be here, and then this is the hypotenuse, and then here is theta, and the opposite, and we're told to find x here, so this would be opposite, so we would use sine. Now, the next one is cos. So cos of theta is equal to adjacent over hypotenuse. And an example of this would be when this is the hypotenuse, and then you're told to find x over here, and the theta is over here, so here is the adjacent, so you would use cos. And then finally, tan is equal to opposite over adjacent. Now, and the example would be here, and you're told to find x, and you are given here. So this is the adjacent, and this is the opposite. So when in a situation like that, you would use tan. This is tan of theta. Now, once you've gotten used to this, you can use trigonometry to solve for x. Now, one easy way to remember these formulas, so opposite over hypotenuse is sine, cos is adjacent over hypotenuse, and tan is opposite over adjacent, is using this mnemonic device, which would be toa. Now, the first three letters would be referring to sine, then the next three referring to cos, and then the final three are referring to tan. You might have seen this before. And just, you can get your equations from the letters. So in sine, the O is referring to opposite hypotenuse. So opposite over hypotenuse. And then in cos, so here is referring to sine. Then C is for cos. So A is for adjacent. And then H is for hypotenuse. So adjacent over hypotenuse. And then the final pairing, which would be T, stands for tan. And then the O is opposite. And then the A is adjacent. So opposite over adjacent. And this would be the best mnemonic device you can use in order to memorize these three formulas. Now, once you've done this, we can solve problems like this. So let me just give out this quick example. So say this can sometimes be given in word problem format and you'll just have to create it, but I'll just give the drawn version. So that's one of our legs, and then we have this here, and then one right here. So this is our triangle, and say we're given this side, so we're given this leg as the value of x. And then this other leg, we're given the value of 18 meters. And of course, this would be a 90-degree triangle. And then instead of theta, as we had discussed, we are given an angle of 62 degrees. And now the problem is asking us how we solve for x. How do we get to the value of x? Now, here we have to look at what things we are given. So, what values are we given so far? We are given our values that we have at the start. So, let me just write starting. So, our starting values are, we have x, 18 meters, and 62 degrees. Now, what we can deduce from our starting values is that we have a 90 degrees here. We're given 90 degrees here, but that just determines that it's a right triangle. And we have no theta given, so there's no obvious theta. And instead, rather than just giving us theta, we're given a value for theta, and we're asked to solve for one of the legs. Sometimes you can get a leg and asked to solve for theta, but in this case, we're given theta and asked to solve for a leg. So that means our 62 degrees is equal to theta. And knowing that it's theta is important because we can later plug it into this equation that I've written out, one of the formulas that I've written out on the top. Now we have 18 meters, which is one of our legs, and x, which is another one of our legs. So this is, if this is our theta, 18 meters is the side adjacent to theta. Adjacent is right next to. So theta is right here, and right next to it is 18 meters. So 18 meters is adjacent. And then once again referring to the location of theta, where's our x? So our x is opposite of theta. It's all the way across the triangle. So x is equal to opposite. Now, given this information, which formula on the top can we use with the information given? We would have to use tan, because we're given opposite and we're given adjacent and we are given the theta. So we can take all our information here and plug it into tan. We can't do sine because we don't have the hypotenuse, and we can't do cos because we don't have the hypotenuse. So we can go ahead and put in our tan equation here. So tan of theta is equal to opposite over adjacent. And now let's plug that in. So tan of 62 degrees is equal to, our opposite is x over, and our adjacent is 18. And now what you would do is you would try to isolate x. So you would then isolate x, and you would multiply by 18 on both sides. So then you would get the equation of 18 tan 62 degrees is equal to x. And then you can plug that into your calculator. And once you plugged it in, you'll get the answer of x is equal to 33.85 meters. So just to review, our first step was to list our starting values and how they are represented in our according to our theta. So our theta was 62 degrees, and 18 meters was adjacent to theta, and x was opposite of theta. Then we, given our current values, so given the values that we have here, we have opposites, so that fits in with sine and tan, and then we have adjacent, which fits in with tan, so we know that we have to use tan here. And then we just write our tan equation, plug in our values, isolate x, and then plug it into your calculator until you get your final solution. So that is how you solve for x using basic trigonometry. Thank you for watching this video. Be sure to like, subscribe, and watch out for future videos.